All right, so this is going to be a video that talks about the basics of THRSim, specifically how to make a basic code run and operate. Um, this is going to be the start of a larger project where we are going to make a series of LEDs light up in a sequence and then turn off in the reverse order. However, for the first part, I'm just going to talk about how to make one single LED operate. This is going to be starting from the beginning since this is the first video. So it's going to talk about how to start like from opening THRSim. So this right here is the actual application. It's a shortcut that you can set, but you can just open it up by clicking it. So the first thing that you're greeted with is essentially the registers. I haven't really used this part much, so I just keep it on the bottom right. And then the commands window, also not that vital, so you just put it out the way. And then you're going to start coding by selecting a new file. This right here is going to be the biggest window because this is where you're going to be writing your actual code. And for the purposes of our project, first I'm going to show us how to actually start opening an LED that we can operate. So the way you can do that is by clicking the connect button. Then you're going to choose LED, and I'm going to talk about this more into detail a little bit later. But first, we need to select one of the pins, and for the purposes of ours, we have a selection from either pin 0 all the way to pin B7, pin B0 to pin B7. So you're just going to select it and then press connect. And as you see, we have an LED input where you can input a bit, and it's going to be sent to pin B0. And here's our LED right here. So starting from the beginning, um, some key terms that we're going to use. First, let's talk about EQU. EQU is essentially the equivalent of assigning a variable in C++. Um, so that you don't have to like remember every single number. You're going to set up little mnemonics, or you can even put in full words for your code to be remembered by. So that if you want to keep on calling it, you can use that word rather than the storage location. Um, and for the purposes of the code, let's say we would do it like this. We want to have the word LED1 represent our first LED. So we can do LED1, EQU, also known as like equals that or equivalent. And it's going to be $1004. Don't worry too much about this. I'm going to discuss it a little bit later. But this is essentially saying the storage location $1004 is also known as LED1. So if we call on LED1, it will be equivalent to $1004. The next part, we can talk about org. And essentially, what it does, it indicates the initial part of your code. Like it's going to start at a certain location. Let's say if by default it's at B6000, if you wanted to change it to, let's say, C000, then it would count up from that location, C000, C0001, and so on. So essentially, it's just going to be kind of like a counter that as your code progresses, it will keep on going up from there. From what I've seen, um, it does it by threes, and I'll show you that later. But the way you would initialize where the code program starts, it will be like this: org, and then you can set the starting point at $sign C000. So that's where the code will actually start. It's just kind of like initialization, so to say. Now, the next part will be some of the actions that we'll be doing. And you can find more information on this in the lecture 2. I believe in to get more information on uh, EQU and the what is the other one? EQU and org. Yeah, you can find them on page 20. Yeah, 24 and 25. So if you go to lecture 3, it's known as lecture 2 through 5, but specifically lecture 3, it'll be right here if you want more information on it and a couple examples. Um, but for the next part, we're going to talk about LDAA. And essentially, what LDAA, it is going to be loading any type of value, 1 bit value, into the accumulator A location. So the way we will do that is by first using the function LDAA. So LDAA, which will load, let's say if we want to send the decimal number 1, you would do 1. However, it is important to note that for loading something, you need to, and that you're going to be using, you need to use the hashtag, and I'll find it in this file. Maybe it'll work with a control F. Okay, well, I'm just gonna have to scroll through it. LDAA. And for more information on LDAA, let's see where we could find that as well. Yeah, okay, right here. So on page 3, you can see LDAA, and it stands for load 1 byte number into accumulator A, also known as ACCA. And the hashtag, as I said, is a prefix that indicates that the operand is actually the data, not the address. So it would be the actual data that we want to send and not the location where it will be stored. So if you wanted to send the number 1 instead of like a location, you would use the hashtag. And since we do want to send the number 1, we would use hashtag 1 to indicate that it's the number 1 that's being sent. So for the next part, it's going to be STAA, and essentially, it's going to be where we want to store the data from accumulator A, because LDA loads it to the accumulator A. STAA takes that data from accumulator A and stores it wherever we want. For the purposes of our project, and first, let's see if you want to find more information on STAA. You're going to go to, let's see, lecture 3, and you're going to go to page number, let's see. And it's going to be a lot of back and forth. However, the lesson plan is a little bit confusing, but having at least like an explanation to find it will be a little bit easier to follow. Okay, here we go. So if we want to find it, then we go to page 10. And as you can see, you're going to store the value from accumulator A to a location that you want. In our case, we want to load the value 1, which would be representing a high value, to our LED in order for it to turn on. So what we can do is we can store STAA, the value from accumulator A, which is 1, to LED1, which is $1004. So it's saying that we're storing the value 1 to 1004, which is also known as LED. So next, now we're going to talk about why it's important to do port B, why we do the $1004. And that comes from the lesson that we saw earlier. Going back a little bit further. Here you go. This talks about port B. So it says here that port B is an output port only, therefore it does not require DDR, which I'm not sure what it means, but when I do find out, I'm going to make another video on it. Essentially, we have 8 pins to work with. That is 0 to pin B0 to pin B7, which is what we connected our LED to. This is not important. The data sent out. Okay, so the data sent out from port B is register $1004. So if we want to access port B, the register to send that data will be $1004, which is why we have it right here. Since the LED is connected to port B, it needs to access the data from the register 1004. let's see. On at default, the content in 1004 is $0 So looking at, I believe that's hexadecimal. Let me see. $sign is. Hmm. Okay, here we go. Yes. So on its own, port B stores hexadecimal values. And it's saying that on default, it's storing the two-digit hexadecimal value 00, which is just 0. So that means that if we wanted to add something, we would send something through STAA to register 1004, also known as LED1, um, and it would replace the content, which is $00, with the amount that we store, which in our case is a 1 byte data, which is 1, the decimal value of 1. I believe it automatically converts it to hexadecimal. I need to double check. However, essentially, if we want to send any value to port B, we need to send it to this register. And I'm repeating it a lot because it's kind of hard to, um, it's a little bit unintuitive. So the more you can say it, the more it will stick and the more it'll be readily accessible or easy to remember. So that's why we are using port B, because LED, if you're connecting an LED, it will be to an output, which is the output port, which is pin B. So you want the LED to connect to an output port, and the place to do that would be port B. And the data that sends out that the register that sends out that data will be $1004. Okay. So now that we have our completed code, just to talk about what each part does, we start with naming our variable. Instead of having the register, we want to call it LED1. And we want to start at C000. This is just a counter. Next, we want to load the decimal value 1 into accumulator A, which is like some short memory. And then we want to store the short memory of the decimal value 1 into the register $1004. And essentially, since this LED is connected to a port B, it would have a pulse equivalent to 1, which would be high. Because for LEDs, it's only a 0 or a 1, or it's, for this LED. I'm not sure if it's true, but as the more information we know, we'll update the knowledge that we gain. For this purpose, let's just consider LEDs either being off or on. So it's either 0 or any value other than 0. Okay. So now that we have our LED and it's connected to port 0 and it has a pulse being sent to it, if we start our circuit, then this LED should turn on. We're going to save it. I'm going to call it test. All right. So now we're going to turn it on. Okay. So it seems to be a problem. Let's see. Okay. So I see a possible problem in the code, and I'm just going to mention it. I'm not sure if it's going to be the only one, but essentially, what I did was I noticed after right-clicking the LED and pressing connect, as you can see here, it is not connected to our circuit. So in order to fix that, even though I thought I connected it to pin B, in case you run into this problem, you're just going to press pin B 0 for our case and then press connect. So now you see LED input bit pin B0. So it's connected to port B at 0. So I'm going to press OK. And as you see, now it turns on. Okay. So essentially what I just did, I forgot to connect the LED. So it's important that you physically do that in order for your LED to actually turn on. And that's how we get our LED to actually function. In the next video, I'm going to talk about how to get it to turn on, delay, and then turn off. We're slowly building to the final project where we have multiple LEDs turning on and turning off. I believe it'll be 8.